Strength of an electromagnet. Aim: to observe how the strength of an electromagnet depends upon the number of turns of the wire. Materials required: 10 cm long 3 iron bolts or iron nails, enameled copper wire 5 meter, a battery of 2 cells, a simple switch, shoe nails or paper clips, plastic pipe of about 10 centimeters. Procedure: to make an electromagnet, take the enameled copper wire and wind it tightly around the iron bolt in the form of a coil. Let it have 20 turns that run parallel to each other. Make sure that it is coiled in a single direction. Make 2 more electromagnets with 40 and 60 turns. Rub the free ends of the wires of each electromagnet with the sandpaper to remove the enamel coating. Connect the electromagnet with 20 turns to a battery of 2 cells through a switch. You can make a switch using 2 drawing pins and a safety pin fixed on a thermocol in such a way that the safety pin can be rotated freely. When the safety pin touches the drawing pin, the current can pass through the material of the safety pin and the circuit is completed. The switch in this case is said to be in on position. On the other hand, when there is a gap between the 2 drawing pins, the circuit is not complete and the switch is said to be off. Place some shoe nails or paper clips near the end of the bolt. Switch on the current and bring the bolt closer to the nails. Count the number of nails attracted by this electromagnet. Switch off the current. Observe that the coil loses most of its magnetism, though a few nails or paper clips may still cling to the electromagnet. Caution: do not switch on the current for more than a minute at a time, as it will get hot and will drain the battery very quickly. Repeat this activity with other electromagnets of 40 and 60 turns. Instead of an iron bolt, wind 60 turns of enameled copper wire around a plastic pipe and observe if it acts as an electromagnet. Count the number of nails attracted by it. Observations: the coil here behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. That is, the steel pins or nails no longer cling to the iron bolt. Such coils that can be turned on or off are called electromagnets. Larger number of nails are attracted by the electromagnet with more number of turns. The electromagnet with plastic core attracted very less number of nails compared to the electromagnet with iron core. Conclusion: an electromagnet can be made by wrapping a wire around a piece of iron and passing current through it. The strength of an electromagnet depends upon the number of turns of the wire and the core used to make the electromagnet. We can increase or decrease the strength of the electromagnet by changing the number of turns of coil or the core without making any change in the battery.